Hi students, good morning to all. Grade 12 Mathematics, chapter number 2, Inverse Trigonometric Function. What the last class we say about y equal to sin x and sin inverse curve, cos x and cos inverse curve, and last one tan x and its tan inverse curve. Today we will discuss about secant x curve and secant inverse curve, cosecant x curve and cosecant inverse curve, and last one cot x curve and cot inverse curve. Okay, right. First one, y equal to cosecant x. Y equal to cosecant x. So you know this curve y equal to cosecant x. So last class, grade 11, you studied about this curve y equal to cosecant x. The domain of cosecant x. Domain of cosecant x is set of all real number except n pi, n is belongs to z, except n pi, n is belongs to z. So domain mean for all values of x, when this equation y equal to cosecant x satisfied when x is belongs to r minus n pi. R minus n pi mean cosecant n pi. You know cosecant n pi, that is cosecant pi value. Cosecant pi is equal to infinite. You know sin pi is 0, sin n pi is also 0. Sin n pi is also 0. Here cosecant n pi is equal to 1 divided by sin n pi. 1 divided by sin n pi is equal to 1 divided by sin n pi, answer is 0. So 1 by 0 is equal to infinite. For all values of x is belongs to n pi, n is belongs to z, this curve y equal to cosecant x is not defined. Y equal to cosecant x is not defined. Okay, right. And its range of this curve, range of this curve y equal to cosecant x is set of all real numbers except open interval minus 1 comma plus 1. Open interval minus 1 comma plus 1. Here set of all real numbers mean, listen, this is number line minus infinite to plus infinite, minus 1 to plus 1. You know the answer, cosecant pi by 2. Cosecant pi by 2 value is 1. Cosecant pi by 2 value is 1, and cosecant of minus pi by 2 is equal to minus 1. Is equal to minus 1. And cosecant pi by 6, what value? Cosecant pi by 6. Cosecant pi by 6 is equal to, already you know, sin pi by 6. Sin pi by 6 is 1 by 2. Sin pi by 6 is 1 by 2. So cosecant pi by 6, the reciprocal of this value, so 2. Cosecant pi by 6 value is 2. So all values of this function y equal to cosecant x is set of all real number except to minus 1 comma plus 1. But open interval minus 1 comma plus 1, here no values between minus 1 comma plus 1 in this curve y equal to cosecant x. Only this curve is have only minus infinite comma minus 1 close interval. That means y is belongs to minus infinite comma minus 1 close interval union plus 1 comma plus infinite close interval 1 comma open interval infinite. Okay, so this is a range of this function y equal to cosecant x. Y equal to cosecant x. Well, listen. The graph of this function y equal to cosecant x is y equal to cosecant x. Xy plane, take xy plane. Here x value is 0, pi by 2, pi, 3 pi by 2 and 2 pi, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi, and so on, etc. Let us consider minus 2 pi 2 plus 2 pi. So the cosecant value, cosecant 0 is infinite. Cosecant 0 is infinite. You know the sine 0 value is 0, so cosecant value is 1 by 0. Reciprocal of sine 0 value, so 1 by 0 is infinite. Listen, this domain value is x is belongs to set of all real numbers except n pi, values. So put n equal to, put x equal to n pi, n is belongs to z, then y is infinite, y is not defined. This curve cosecant x is not defined at x equal to n pi, n is belongs to z. So the curve, the graph of the y equal cosecant x, the curve in y equal cosecant x curve is does not touch at x equal to pi, at x equal 2 pi, x equal 3 pi, and x equal minus pi, x equal minus 2 pi, and so on, etc. That means this curve is does not touch at x equal to n pi, n is belongs to z. This curve cosecant x is does not intersect at this point x equal to n pi, n is belongs to z. N is belongs to z. Listen, so minus pi, plus pi, 2 pi, and minus 2 pi. And also a range. The range of this function is y is equal to set of all real numbers except open interval minus 1 comma plus 1. Open interval minus 1 comma plus 1. Here y as 0, 1, 2, 3, 4, 5. Here minus 1, minus 2, minus 3, minus 4, minus 5, and so on, etc. So this curve y equal cosecant x is, this range is y equal to r minus open interval minus 1 comma plus 1, set of all real numbers except minus 1 comma plus 1. Here y equal to cosecant x in between 0 to pi, and cosecant 0 is not defined, cosecant pi is not defined. So this curve does not intersect at this point x equal to pi, and x equal to 0, and x equal to minus pi. So here this is y equal to cosecant x in between 0 to minus pi, in between 0 to minus pi. Next, minus pi to 3 pi by 2. You know the value, cosecant of 3 pi by 2. Cosecant of 3 pi by 2. So sine 3 pi by 2 value is minus 1, and cosecant 3 pi by 2 value is also reciprocal of minus 1 is minus 1. So y equal cosecant x at x equal to 3 pi by 2, this value is minus 1. So minus 3 pi by 2 comma minus 1. This point is 3 pi by 2 comma minus 1. Next, minus pi to 3 pi by 2. This is a curve y equal to cosecant x. Okay. Okay, listen. Next, the graph of y equal to cos inverse x. Y equal to cos inverse x. Sorry, cosecant inverse x. This is y equal to cosecant x curve. And next, y equal to cosecant inverse x. You know that the domain of this function y equal cosecant x is belongs to r minus n pi, and also range of this function is set of all real number except to open interval of minus 1 comma plus 1. Okay, right. You know the inverse function, this function is y equal cosecant x. The whole interval x is belongs to r minus n pi, x is belongs to r minus n pi. This function is not bijective. Bijective means 1 1 and onto. This function is not 1 1 and onto at x is belongs to r minus n pi. So let us consider we restrict this domain or minus pi by 2 comma plus pi by 2, minus pi by 2 comma plus pi by 2 except 0, except 0. So minus pi by 2 comma plus pi by 2, here listen, minus pi by 2, this is minus pi by 2, this is plus pi by 2. So this curve is exists between minus pi by 2 plus pi by 2. Minus pi by 2 comma plus pi by 2. This curve is y equal to cosecant x blanks to x is blanks to minus pi by 2 comma plus pi by 2. This curve is does not touch at x equal to 0. This curve does not meet at x equal to 0. That means at x equal to 0 this curve is does not exist. Okay. So minus pi by 2 comma plus pi by 2 except close interval of minus pi by 2 comma plus pi by 2 except 0. Except 0. So this curve is exists between minus pi by 2 comma plus pi by 2 but does not exist at x equal to 0. So this is a principal domain of this function y equal to cosecant x. Minus pi by 2 comma plus pi by 2 close interval except 0 is a principal domain of this function y equal to cosecant x. Here minus pi by 2 comma plus pi by 2 except 0 is principal value. Principal value of this function cosecant inverse x. Cosecant inverse x. So inverse function here domain and the range is interchange. So interchange the domain and range. Here the domain of this function y equal to cosecant inverse x is this principal value, this range or set of all real number except the minus 1. So set of all real number except open interval minus 1 comma plus 1. This is the domain of this function y equal to cosecant inverse x. And range of this function is range of this function y equal to cosecant inverse x is close interval minus pi by 2 comma plus pi by 2 except 0. Except 0 value. At x equal to 0 this function y equal to cosecant inverse x also does not exist. So minus pi by 2 comma plus pi by 2 except 0. This is a range of this function cosecant inverse x. Okay, right. Right. Draw the graph of y equal to cosecant inverse x. You know the domain of this function is set of all real number except open interval minus 1 comma plus 1 and the range of this function is close interval minus pi by 2 comma plus pi by 2 except 0. This is domain and range. Right, listen. X, y. Here x-axis is 0, pi by 2 and pi, 3 pi by 2 and 2 pi and so on etc. Interchange the domain and codomain value. Here domain is x is belongs to r minus n pi. But here domain is r minus open interval minus 1 comma 1. That means the domain of this function cos inverse x is equal to a range of this function domain of the cosecant inverse function r minus open interval minus 1 comma plus 1 is a range of this function r minus open interval minus 1 comma 1. Okay, domain of cosecant inverse x is equal to range of this function y equal to cosecant x. Okay, right. So x, you can take x value 0, 1, 2, 3, 4, 5 and so on etc. And minus 1, minus 2, minus 3, minus 4. Y value is 0, pi by 2, pi, 3 pi by 2, 2 pi minus pi by 2 minus pi minus 3 pi by 2 and minus 2 pi minus 2 pi. You know the answer? Cos inverse of 0. Sorry, cosecant inverse of 0. So cosecant inverse of 0 is not defined. Cosecant inverse of 0 is not defined. Listen, cosecant 0 is not defined. So also cosecant inverse of 0 is also not defined. Cosecant inverse of 0 is not defined. Listen, this function is exists from 0 to pi by 2, 0 to pi by 2 open interval. At x equal to 0 and x equal to pi by 2 does not exist this curve. Okay, so listen, and also same 0 to pi, the range of this function 0 to pi and 0 to minus pi. Limit 1 minus 1 to plus 1. Here domain of this function is set of all real number except to minus 1 comma plus 1. Minus 1 comma plus 1. That means this curve cosecant inverse does not exist between minus 1 to plus 1. Between this value minus 1 to plus 1. So this curve does not exist between open interval of minus 1 comma plus 1. Okay, right. So this curve exists this is a y equal to cosecant inverse curve. Y equal to cosecant inverse curve. So here the limits range is minus pi by 2 comma plus pi by 2 to 0. Minus pi by 2 comma plus pi by 2 to 0. So the only the cosecant inverse exists between minus pi by 2 comma plus pi by 2. So this is plus pi by 2. This is minus pi by 2. So this curve is exists between the value is minus pi by 2 to 0 open interval, minus pi by 2 to 0 open interval and 0 to minus pi by 2. 0 to minus pi by 2. So cosecant inverse of minus pi by 2 is minus 1. Cosecant inverse of minus pi by 2 value is minus 1. This is the cosecant inverse curve. This is the cosecant inverse curve between minus pi by 2 plus pi by 2 at x equal to 0. This curve does not meet at x equal to 0. At x equal to 0, this curve cosecant inverse does not exist. Okay, so x equal to 0, this the curve exists. Okay, only minus pi by 2 to plus pi by 2 answer except 0. The curve 0 touch பண்ணுதா இல்ல சரியா? So this curve does not meet at x equal to 0. ஓகேவா? இப்போ வேல்யூ வந்து y equal to 0 நமக்கு கிடைக்கும். cosecant inverse of any value is not equal to minus 1 comma plus 1. இந்த வேல்யூ நமக்கு கிடைக்காது எப்போதுமே. only you have minus pi by 2 comma plus pi by 2 except 0 மட்டும் தான் இருக்கும். இந்த minus 1 to plus 1 எடுத்தேன் சாரி pi by 2 comma plus pi by 2 except 0. இந்த வேல்யூ மட்டும் தான் கிடைக்கும். ஓகேவா? வேறு எந்த வேல்யூ எடுத்தாலும் நமக்கு கிடைக்காது. ஸோ இன் பிட்வீன் மைனஸ் பை பை டூக்குமா ப்ளஸ் பை பை 2 எக்ஸப்ட் 0 இந்த ரேஞ்ச் மட்டும் தான் கிடைக்கும். எப்போ அப்படின்னா cosecant inverse எக்ஸிஸ்ட் ஆகணும். ஏன்னா நமக்கு இந்த லிமிட்டுக்குள்ளே மட்டும்தான் எக்ஸிஸ்ட் பண்ண முடியும். ஸோ திஸ் ஃபங்க்ஷன் cosecant inverse எப்போ எக்ஸிஸ்ட் ஆகுது, ஏதாவது பைஜெக்டிவ் ஃபங்க்ஷனை கன்வெர்ட் ஆகும் அப்படின்னா லிமிட் மைனஸ் பை பை 2 டு ப்ளஸ் பை பை 2 ஒன்லி. ஸோ அதனால தான் அந்த பிரின்சிபல் டொமைனை நம்ம இங்கே பிரின்சிபல் வேல்யூவாக கன்சிடர் பண்ணுறோம். ஓகேவா? புரியுதா? ரைட். Listen. Next, second one, y equal to secant x curve. Y equal to secant x. So you know the domain of this function y equal to secant x is domain. Y equal to secant x is reciprocal of cos x. Okay. You know the cos x domain. The domain value of cos x function is a set of all real numbers. Set of all real numbers. But this function is a reciprocal of cos x function. When cos x equal to 0, this function secant x is not defined. Cos x equal to cos x value is 0. So this function y equal to secant x is not defined. So cos x at x equal to 2n plus 1 into pi by 2 and cos x value is 0. So therefore this function secant x is does not exist at x equal to odd multiple of pi by 2. Odd multiple of pi by 2. That means odd multiple of pi by 2 means 1 pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2 and so on etc. This is odd multiple of pi by 2. So we have take x equal to 2n plus 1 into pi by 2, n is belongs to z. This function secant x is does not exist. That means does not define, not define. Okay, listen. A domain of this function secant x is set of all real number, set of all real number except, that means minus 2n plus 1, 2n plus 1 into pi by 2 n is belongs to z. 2n plus 1 into pi by 2 n is belongs to z. Why sir? Here substitute this value 2n plus 1 into pi by 2 anyone. Put n equal to 0. n equal to 0. We have take 0 plus 1 into pi by 2. That means 0 plus 1 into pi by 2 is 1 pi by 2. So put x equal to pi by 2. X equal to pi by 2. Which implies cos pi by 2 is 0. Cos pi by 2 is 0. And secant pi by 2 1 by 0. Secant pi by 2 value is 1 by 0. So 1 divided by 0. You know, any number divided by 0 is not defined. So this is infinite. And the same similar to odd multiple of pi by 2, you can take any value in odd multiple of pi by 2 in x. Then this function y equals secant x is not defined. Y equals secant x is not defined. So the domain of this function secant x is set of all real number except 2n plus 1 into pi by 2 n is belongs to z. Except 2n plus 1 into pi by 2 n is belongs to z. This is a domain. Right. A range. Range of this function y equals secant x. Range of this function y equal to secant x is set of all real number, set of all real number except say minus 1, open interval minus 1 comma plus 1. Open interval minus 1 comma plus 1. For example, cos pi by 6. Cos pi by 6. Cos pi by 6 value is root 3 by 2. Root 3 by 2. Here root 3 by 2 value is root 3 is 1.7 something divided by 2. So 1.7, here root 3 is less than to 2. Here root 3 is smallest value and root 2 is biggest value compared to root 3. So root 3 is less than to 2. So this value is less than 1. Root 3 by 2 is equal to any less than value. So 1.7 divided by 2. 1.7 divided by 2 is less than 1. That means 0 is less than, this value 1.7 divided by 2 is less than 1. So in between 0 to 1. In between 0 to 1. Suppose secant pi by 6. Secant pi by 6. So secant x is also reciprocal of cos x value. So secant pi by 6 is reciprocal of root 3 by 2. So 2 by root 3. 2 by root 3. Here 2 is greater value compared to root 3. So 2 is greater than to root 3. So also 2 by root 3 is equal to greater than 1. Greater than 1. So 2 divided by 1.7 something is equal to 1 point something. So this value is greater than 1. Okay. So the secant x have only set of all real numbers except minus 1 comma plus 1. Except minus 1 comma plus 1. Secant x oda value the minus 1 comma plus 1 open interval varadu. Idu thavira matha ella varum. Minus 1 to plus 1 example 0.1, 0.5, 0.7, minus 0.7 இந்த வேல்யூலாம் நமக்கு கிடைக்காது. மைனஸ் 1க்கு ப்ளஸ் 1 இடையில எந்த வேல்யூ நமக்கு secant xக்கு எக்ஸிஸ்ட் ஆகும் வரதுக்கு சான்சஸ் இல்லை. ஓகேவா? அது எல்லாமே என்ன இருக்கும், இந்த ஓப்பன் இன்டர் மைனஸ் 1 ப்ளஸ் 1 தவிர அதுக்கு வெளியில் உள்ள வேல்யூ மட்டும்தான் வரும். ஓகேவா? ஃபார் எக்ஸாம்பிள் range is equal to, that is minus infinite to minus 1 close into open interval union 1 comma infinite open interval. இது மட்டும் தான் எக்ஸிஸ்ட் ஆகும். அதாவது என்ன மீனிங் அப்படின்னா the real line 0 minus 1 plus 1 minus infinite to plus infinite. The domain r minus 2n plus 1 pi by 10 is belongs to z இருக்குல்ல, the domain value for all values of x, then this value of y is equal to only minus infinite comma minus 1 close interval and also plus 1 comma close interval plus 1 comma infinite 1. ஓகேவா? அப்போ இந்த சீக்கன் எக்ஸோட வேல்யூ இதுக்குள்ளே எந்த வேல்யூவும் கிடைக்காது. இந்த -1 to +1க்குள்ளே இடையில உள்ள எந்த வேல்யூவும் சீக்கன் எக்ஸ் எப்போதுமே வராது. ஓகேவா? இதுக்கு வெளியில் மட்டும்தான் வரும், உள்ள எந்த வேல்யூவும் வராது. அதான் மீனிங். ஸோ த ரேஞ்ச் ஆஃப் திஸ் ஃபங்க்ஷன் சீக்கன் எக்ஸ் இஸ் set of all real number except -1 comma +1. That is open interval of minus infinite comma minus 1 close interval union close interval of 1 comma infinite open interval. Okay, this is the range of this function. So draw this graph of this function y equal to secant x, x y 0 pi by 2 pi 3 pi by 2 and 2 pi minus pi by 2 minus pi minus 3 pi by 2 and so on etc minus 2 pi minus 2 pi. Put x equal to r minus 2n plus 1 into pi by 2. That means except pi by 2, 3 pi by 2, 5 pi by 2, minus pi by 2, minus 3 pi by 2 and so on etc. அப்போ எக்ஸுக்கு minus pi by 2 plus pi by 2, 3 pi by 2, minus 3 by 2 இந்த வேல்யூ சப்ஸ்டியூட் பண்ண எக்ஸிஸ்ட் ஆகாது. So this curve secant x curve does not intersect at x equal to pi by 2, x equal to minus pi by 2 and x equal to 3 pi by 2, x equal to minus 3 pi by 2. இப்போ இந்த pi by 2ல இந்த curve டச் பண்ணாது, அதே போல் 3 pi by 2ல டச் பண்ணாது, ஏன்னா நமக்கு எக்ஸிஸ்ட் ஆகாது. ஸோ இன்ஃபைனைட் வேல்யூ தான் கிடைக்குது. ஸோ minus pi by 2லேயும் நமக்கு கட் ஆகாது, minus 3 pi by 2ல கட் ஆகாது. ஓகேவா? ஸோ the limit range என்னென்ன கொடுத்துருக்கோம், set of all real numbers except open interval of -1 comma +1 சொல்லியிருக்கோம். இப்போ -1 this is +1 here -1. இந்த -1க்கும் +1க்கும் இடையில் நமக்கு எந்த வேல்யூமே கிடைக்காது சொல்லுவோம். சரியா? ஸோ the curve only exists between except minus set of all real number except -1 comma +1. So the y equals secant x curve is passes through 0 comma 1. This curve does not touch at x equal pi by 2. இந்த curve எங்கே டச் பண்ணியிருக்குதா, இந்த லைனை டச் பண்ணாது. ஸோ டச் பண்ணாது இன்ஃபைனைட். At x equal to pi by 2, secant pi by 2 value is infinite. Secant pi by 2 value is infinite. So this curve y equals secant x curve is does not touch at x equal to pi by 2, x equal minus pi by 2. Okay, right. Next, this is -1 line and minus pi by 2 to 3 pi by 2. The curve is touch at x equal to pi. When x equal to pi, secant pi value is -1. Cos pi value is also -1. Reciprocal of -1 is also same -1. So this curve passes through pi comma -1. Pi comma -1. Next, cos of minus pi -1 and also same secant of -5. Answer -1. So minus pi comma -1. This curve does not touch at x equal to minus pi by 2 and x equal to minus 3 pi by 2, x equal to pi by 2 and x equal to 3 pi by 2 and so on etc. Odd multiple of pi by 2. This curve does not beat at the point odd multiple of pi by 2. Okay, this is a secant x curve. This is a secant x curve. Okay. Next, listen. Next is secant x curve. Y equal to secant inverse x curve. Y equal to secant inverse x. This is y equal to secant x. This function is y equal to secant x. This function is y equal to secant inverse x. When the secant x, this function is invertible when the principal domain x is belongs to here, domain is r minus 2n plus 1 into pi by 2, n is belongs to z. But this function secant x is invertible. That means f inverse, f of x equals secant x, then secant inverse is x is when x is belongs to x is equal to x is belongs to 0 comma pi, close interval of 0 comma pi, except here at x equal to pi by 2 and minus pi by 2, this curve does not exist. So 0 comma pi except pi by 2, except pi by 2. So last curve y equal to cosecant x curve. The principal domain of the cosecant x curve is x is belongs to minus pi by 2 to plus pi by 2 close interval except 0. At x equal to 0, cosecant x is not defined. At x equal to 0, cosecant x is not defined. So cosecant x is also not defined. Here secant x curve at x equal to pi by 2 and minus pi by 2, pi by 2 and minus pi by 2 and so on etc. odd multiple of pi by 2. This curve secant x is not defined. So but this curve whole interval, this curve is not 1 to 1 and onto function. That means not a bijective function. So we restrict this domain. We have taken the principal domain of 0 comma pi. So principal domain of the cos x function is close interval 0 comma pi. You know the principal domain of a cos x function is 0 comma pi. Here the principal domain of this function secant x is close interval 0 comma pi except pi by 2. Except pi by 2. When x equal to pi by 2, this curve does not exist. So the principal domain of this curve y equal to secant x is belongs to 0 comma pi except pi by 2. Listen, here domain of the secant inverse x function is, domain of this secant inverse x function is equal to range of this secant x function. Range of this secant x function. Here range value is set of all real number except open interval minus 1 comma plus 1. This is the domain of secant inverse x. So set of all real number except open interval minus 1 comma plus 1. This is the domain. Next, range of this function secant inverse x is principal domain of secant x value. That is, this is 0 comma pi, close to 0 comma pi except pi by 2, except pi by 2 is principal value of this function secant inverse x. That is a range. So the range of secant inverse x is close interval of 0 comma pi except minus pi by 2. So the definition is secant inverse x related to r minus 1 comma plus 1. This is domain. So related to range is 0 comma pi except pi by 2, except pi by 2. This is a definition of secant inverse x. Okay, right. Listen, trace the curve in secant inverse x y. Here domain value and range value, and secant inverse x interchange the domain and range value. Here domain is minus of all real numbers except minus 1 comma plus 1. That means 0, 1, 2, 3, 4, 5 and so on etc. Here minus 1, minus 2, minus 3, minus 4 and so on etc. Y axis has 0, pi by 2, plus pi, 3 pi by 2 and 2 pi, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi, minus 2 pi. Right. Here domain is set of all real number except minus 1 comma plus 1, and range value is 0 comma pi except pi by 2, except pi by 2. Listen, this curve is secant x curve. This is a secant x curve, and secant inverse x at x equal to pi by 2, this curve does not exist. This is y equal to pi by 2, y equal to pi by 2. This is y equal to minus pi by 2. This is 0 comma pi, 3 pi by 2. The curve This is a secant inverse x curve. Secant inverse x. This curve does not meet at y equal to pi by 2. This curve does not meet at y equal to pi by 2. Why sir? Here range of this function is 0 comma pi except pi by 2. Except pi by 2. So this curve does not meet at x equal to, sorry, y equal to pi by 2. This is 1. Minus 1. Minus 1. Listen, at x equal to, at y equal to pi, this curve x is equal to minus 1. At x equal to minus 1, y is equal to pi. Secant inverse of, secant inverse of minus 1. Secant inverse of minus 1 is equal to pi. Secant inverse of minus 1 equal to pi. At x equal to minus 1, y equal to pi. So minus 1 comma pi. Minus 1 comma pi. But this curve does not meet at x equal to pi by 2. So this curve does not touch this line y equal to pi by 2 line. Given so the range of this function is 0 comma pi except pi by 2. 0 comma pi except pi by 2. So this limit, this is 0 to pi. So this is a range limit. Except pi by 2. This line is pi by 2. Okay, so the secant inverse x curve, this is a secant inverse x, this only, and this only. This is a secant inverse x curve. When the range is 0 comma pi except minus pi by 2, the secant inverse x exists. Suppose the whole, we can take the whole interval when the secant inverse x does not exist, then the function secant x is not 1 1 and on 2. So we have to restrict this domain x is belongs to 0 comma pi except pi by 2. So this value is the range of this function secant inverse x, 0 comma pi except pi by 2. So the curve is, this is a secant inverse x curve. Curve 1 meet 1 குள்ள வராது, -1 க்கு +1 க்கு இடையில நமக்கு curve exist ஆகாது. அதனால இந்த curve வந்து -1 க்கு +1 குள்ள வராது. ஓகேவா? at x equal to pi by 2 ல இந்த curve மீட் ஆகாது. ஏன்னா நமக்கு ரேஞ்ச் என்ன சொல்லிருக்காங்க, 0 to pi குள்ள கொடுக்கலாம். அப்ப 0 ல இருந்து pi வரை இதுவரை எல்லா வேலையும் எடுத்துக்கலாம். எதை தவிர எடுத்துக்கணும், except pi by 2. except pi by 2. சோ இந்த curve எங்கயாவது pi by 2 ல மீட் பண்ணிருக்கா? இல்ல. ஓகேவா? சோ இந்த pi by 2 ல இந்த curve exist ஆகாது. அதனால 0, pi close interval, this is a range set except this value y equal to pi by 2. ஓகேவா? அதனால தான் மற்ற இது மட்டும் தான் நமக்கு y equal to secant inverse curve. whole value எடுத்துட்டோம் அப்படின்னா secant inverse exist ஆகாது. அது ஒரு ஃபங்க்ஷனாக, இஸ் நாட் ஏ ஃபங்க்ஷனாக மாறிடும். ஓகேவா? இவ்வளவுதான் secant inverse x. ஓகே, ரைட். Okay students, today class is over. Once again, y equal to secant x and secant inverse x, y equal to cosecant x and cosecant inverse x. You prepared very well in domain of this curve y equal cosecant x and y equal secant x, and also range of this curve y equal cosecant x and y equal to secant x. Similarly, same domain and range of this function secant inverse x and cosecant inverse x. Very very important, domain and range. Okay, right. See you next class. Okay, bye.